Now in last week's video I showed how I came up with the idea of this compressed air engine, 3D printed it and then built it and then tested it, and it seemed to run really well. However, I also explained that I'm going to experiment with adjusting the angle of this cam at the bottom here. Initially I designed the cam to be 20 degrees behind the crankshaft, so just as the piston reaches the top, the valve starts to open, and then as the piston's coming down, the valve is fully open, and then it obviously shuts as the piston gets to the bottom. So this latest cam, I have delayed it by 60 degrees to the crankshaft. So the piston is already probably about a quarter of the way down the cylinder by the time the valve is fully open. So most of the air is going straight into the cylinder to push it down rather than being compressed and then expanding in the cylinder. And I'll just give you a quick demo of how this runs. Okay, so this is at 60 psi, which is the same pressure I tested it as last time. In 3, 2, 1. So if I show a quick clip from last week's video, you'll notice that it sounds quite a bit different. 3, 2, 1. Now I haven't watched the videos back to back because I've just recorded it now. However, I'm pretty sure this is quite a bit longer runtime than the previous cam design, and also this was run at the same pressure of 60 psi. So yeah, it might be ready to mount on a plane. So let's go build a plane.
So vicious. We're going to get attacked on.
I don't think he knows that we're doing a really scientific experiment right here.
Safety first, kids. One day that's going to bite you.
Ready?
Yeah.
What do you reckon I should give it pressure wise?
Don't know. 45, 60?
Yeah, I'm thinking 50, just good round number. Oh, I'm already at 60. Oh, that was quick.
Looks like it's 60 for the first fight.
Right, are you ready?
Always.
Hope I'm still in frame on the drone. 3, 2, 1. Fail. 3, 2, 1. It was spinning faster yesterday. Right. See what I mean by it spins forever?
Yeah, it doesn't stop.
Right, so what I'm thinking, too low RPMs. I am going to get a smaller propeller and hope that it will spin at a higher RPM. So we've got a smaller APC propeller on there, hoping for higher RPMs. Just going to do a quick test before I throw it into the ground again. And the bike pump isn't on properly. Quick test at 40 psi. In 3, 2, 1. The RPM seems a lot higher now, so we might be good to go. 60 psi again, do you reckon? Or
Yeah, we could go higher.
I don't think I've tried it with this propeller at 60 psi. What if the engine just blows up? Hits the rev limiter. These stupid bike valves are leaking more than my engine is. Right, there we go, 60 psi. Come off.
The transmitter's over here.
Are you ready?
Yeah.
So launch from my other hand now and then just... I don't know which hand to launch with. In 3, 2, 1. That was such a terrible launch.
It looked pretty twitchy on the elevator. Or maybe that was just you.
Ready? Still got more air in it.
Use more power.
More pressure or a smaller prop?
More pressure. Because otherwise I think you're going to lose too much static thrust.
I'm kind of tempted to get my ear defenders on.
What did you test the other ones at? Pressure wise?
I haven't gone above 60, 60 on this.
You've been to higher before though, haven't you?
It's not. I don't think it's the bottle I'm worried about. I think it's the engine cap. Because if that blows out, it's basically going to fire the bottle the other way at like stupid speed.
You're holding the bottle though, so.
Yeah, but if I'm holding it like that and it just goes, it hits me in the face. I'm going to have a bike valve through my face. I hate these bike valves.
Why'd you use a Presta valve over a Strada or whatever it is?
Because this one is these come like with a threaded bit, with a rubber bit, so it's really easy to seal into things.
Oh, okay, right, yeah. It's easier to depressurize as well. You don't have to like poke the pin. You can just press the thing.
Yeah, exactly. Yeah. That's 80. Are you ready?
Yep.
3, 2, 1. I think it's stalled.
That was better.
I wonder if it's worth sticking it in a car.
What?
Wait, I'll just get a land because this wind's coming.
What do you mean stick it in a car?
Make an air-powered car.
Oh, that could be quite cool.
One more time. We got this. One more time. Just
100 psi.
I can't knock it on the head without going all out. So I'm not really sure what else to do with this plane apart from going all out. So that's what I'm gonna do after I've put the drone in position. Okay, let's go. 100 psi. 100 psi, and hopefully I don't die.
100 psi. Steps back.
Even if this doesn't work, at least I can say my 3D printed bottle lid can hold back more pressure than this this bike valve. That's 100, that's 100. Right, I'm launching with my right hand because I'm better with that one. Right, you ready?
Yep.
Set.
Best attempt yet.
Right, I think I'm going to call it there. Jesus.
It's probably still got 80 psi in there.
I was trying to play that out as some kind of comedic effect, but it lasted way too long. Such a pain we couldn't get it to work. What the hell? Put the plane out of view, and I'll be pretending to pack up my Mavic, and then I'll edit in the sound of the engine, and then I'll be like, and then you just like pan up, and then I'll switch to the next view. Yeah?
Yeah.
How high do I go? What if it just falls off now, nose dives? Right, so if you go stand over where it took off from, oh god, oh god.
Run!
So I woke up this morning and realised I'd completely forgotten a major thing with this whole cam mechanism. As I mentioned at the start of the video, I can adjust the angle of the cam to trigger the valve at any point during the cycle to try and get the best efficiency and also runtime. But what I'd completely forgotten is that I can actually change the profile of the cam. Now this profile here, it's got just a point where it will push the valve, just quickly poke it at one point in the cycle. Whereas I've designed this new cam, which has a slightly larger radius at the top. I don't know if the camera focuses on that. Has a slightly larger radius, which will hold the valve open for a longer period of time, which I'm hoping will be able to let more air into the cylinder per stroke, which theoretically I think will increase the torque. So what I'm thinking is that with this torque increase, it should be able to increase the RPM of the propeller. As you saw in the first tests, as I went from the bigger propeller to the smaller propeller, the RPM increased because the torque wasn't limited by having to spin that huge propeller. So hopefully by having the valve open for longer, the torque will increase, which will be able to put more force into the propeller, which will hopefully make it spin faster. Right, enough of the talking, let's quickly test it out. So this is the old cam at 40 psi. 3, 2, 1. So this is the new cam at 40 psi. In 3, 2, 1. Ooh. In 3, 2, 1. That seemed like a lot higher RPM and a lot shorter runtime. I need to look back at the footage to double check, but for now I'm going to go test fly this outside whilst the sun is out. Let's go. So it's quite early in the morning and this thing is super loud, this engine. I don't really want to make too much noise, but this is the last few hours of sunlight before the rain kicks in this week, so I haven't even done my hair yet, and let's go for one final test with this new cam design. I think I might just go straight away up to 100 psi. Let's go. So it turns out that starting these air engines are pretty dangerous. I think I sliced up my finger pretty bad. Doesn't hurt. It's bleeding a lot. Right, so I managed to get some kitchen roll, and I think I found out why the engine wasn't starting. The propeller came loose, and it wasn't doing the flywheel effect, so the propeller was just spinning, and then when it actually gripped, that's when it sliced my finger open. These things are dangerous, guys. So I think that's probably the best result I'm going to get out of this plane. The new shaped cam definitely increased the power output. I could definitely tell it had more, or slightly more RPMs. I can't really add more torque as far as I'm aware, because that cam holds the valve open for almost a whole stroke downwards. So it's max torque right now. Obviously shorter flight time with that max torque because the valve's open longer, more air is wasted. The only other thing I can think of is whether I can somehow gear this to a higher RPM so it utilises that torque a bit better rather than just spinning up to a max RPM, losing all the torque and everything. Maybe I can gear it so that it doubles the RPM at the prop in comparison to the engine. I'm not sure. As you can see, I've tried my hardest to make this video good, but I think I'm going to call it here. This was the last try of this plane. I think what I'm going to have to do is go back to the drawing board, do a bit more thinking, a bit more calculations as well. This plane was a bit rushed. It's quite hard to do a project like this where it's so engineering spec based. It has to be so precisely made, and I've kind of just taken a hacksaw to an A380, if that makes any sense at all. So I'd like to thank you very much for watching. If you enjoyed this video and my little experiment, then please leave a thumbs up. I learned quite a bit from this, that the engine doesn't spin fast enough. It has quite a bit of torque because it managed to chop through my finger. Doesn't spin fast enough, so I need higher RPMs for higher flight velocity. And the flying wing design, it works alright. There was a bit when it got into ground effect actually, which worked quite well. But yeah. If you're new to my channel, please click subscribe, and a huge thanks to all my patrons for supporting me. You guys make these weekly videos possible, and if you wish to support me on Patreon, then click the box that will probably appear somewhere up here, or no, it'll appear here. It'll appear here. That's it. Alright, see you next week. Goodbye.